Okay, 15.3, rational exponents. This lesson is going to be more or less just kind of some examples of what you're going to see in some of your homework problems. We'll get to the more examples in some of the other videos, and also I'll do them in class, and plus below this, of course, and below in the notes, you'll be able to have some examples. But let's just kind of go through what's happening here. Notice that we are now leaving just the square roots. Now we're going to have square roots, cube roots, fourth roots. They're going to be roots of any type. Okay, and you're going to see them in the form of this, like, let's use square root since it is something that you all should be very familiar with now. Notice if b equals the square root of a, there is a invisible 2 there, okay? That can also be rewritten as b equals to the power of 1/2, okay? That may not seem, you may be thinking why, but you'll see why in a little bit. When you turn this into an exponent, it makes the math a lot easier. Okay, so notice here 3 is equal to the square root of 9, which is also equal to 9 to the power of 1/2. Okay, same thing here. We've got a 3. Okay, kind of work its way through. Yeah, pretty straightforward here. Just kind of whatever your denominator is, okay, that is going to become your index. Okay, so denominator to index. Notice here you got a 1 here. Well, this 1 in your numerator, that is going to be associated with whatever's inside. So if there was a 2 in here, you could literally say that you have a to the power of 2 inside that square root. You will see some of these in your homework. We'll go through some examples, so don't stress. Moving on, this is just kind of the formal rule of that. If you'll notice that when you have a to the m over n, you can have that and that. Well, notice that this kind of just gets kicked out. This stays up under the radical, okay? So this right here becomes the index. This right here becomes the power, okay? Moving on, something very special to kind of realize here. For the expression of n to the square root of a, or 1 over n to the power, or a to the power of 1 over n to be a real number, assuming n is an integer greater than 1. Okay. When a is non-negative, n can be any index. What it's saying is when this number's non-negative, means greater than 0, n can be any number. Okay, that's flat out what it just says. But what it says is when a is negative, n must be odd. This goes back to the old rules of, like, can you have something like that? Yes. Okay. But can you have something that looks like that? And that's a no. It's a non-real answer. Okay? And that's what it's saying. Notice I can have any index I want here. Okay? Because we're dealing with nth roots now. Well, so now I can have 4, 5, 6, 7, 8. And if it's an odd number, then yes, I can have a negative. But if it's even, then I cannot have that. Okay. Continuing on. We got some rules for exponents. This is just going to be one of those things you're just going to have to look at. Okay. We've pretty much by this point gone over everything. I can't think of anything we haven't yet. Yeah. And just some more rules. I'm trying to think if there's any on here. This is going to be one you're really going to want to remember right here. Just remember, anytime you have a negative, okay, it's going to shoot that on the bottom. But notice here, if you have a negative in the denominator, it gets shot back up to the top. Okay? Just going to be one of those things you're just going to have to kind of remember. We did a lot of that during the simplification process stuff. So, let's see, continuing on. And then once again, just some examples. Okay? This is just, it's the same thing as saying, what's the square root of 49? It's 7. Well, because 7 to the power of 2 is 49. What's the fourth root of 81? Well, that's like taking this is not like, it's taking the square root of 81, which is 9, and then taking the square root again, which is 3. That's what a fourth root is. You're taking the square root twice. Here, of course, you can have a negative in here, so we know that the cube root of 8 is 2. Well, the cube root of negative 8 is just going to be negative 2. And then here we've got this really long, very scary looking decimal that we're going to go ahead and take the fifth root of. Well, notice they're just moving that decimal over 1, 2, 3, 4, 5. Okay, so you get this here. 1, 2, 3, 4. Nope, sorry. Yes, so I thought. Okay, so you get 0.1. These right here, I do a lot on calculator. Okay, just in case, better safe than sorry. And of course, this one, notice here, I have an even N with a negative number there. That means this is not a real number. Okay, so like I said, we'll do more of these in the we did them in class, and we've got more in the notes section. So.